Hello there and welcome to the June 2019 paper. Here we're looking at question 4. The line L has equation x plus 2. Actually, I'm going to rewrite this plane here, this line here, because this form here isn't particularly helpful at all. So it's minus 2, 5, 4 plus lambda lots of 1 minus 1 minus 3. Okay, so that's better, and the plane has equation. In fact, I'm going to rewrite this as well. It's going to be rewritten as x minus 2y plus z equals minus 7. So that's a better way of writing a plane there. Determine whether the line L intersects pi at a single point, or lies in the plane, or is parallel to the plane without intersecting it. I think what I'll do first, so I'll try and find the intersection point. So if I try and find the intersection point, the line has this equation here, minus 2 plus lambda, 5 minus lambda, and 4 minus 3 lambda. So what I've done there is I've just taken the equation for line L and put it into one single vector. And now what I'm going to do is I'm going to sub this into the plane. So substituting it into the plane, the top row is x, the middle row is y, the bottom row is z, then it's going to be minus 2 plus lambda, minus 2 lots of 5 minus lambda, and then plus 4 minus 3 lambda equals minus 7. If we expand these brackets, we're going to get minus 2 plus lambda, minus 10 plus 2 lambda, plus 4 minus 3 lambda equals minus 7. So let's simplify it down now. Let's cancel out the lambda, 2 lambda and minus 3 lambda. Oh, so all of my lambdas have actually disappeared, and on the left hand side what I'll end up with is minus 2 times, add minus 10 is minus 12, add plus 4, minus 12 plus 4 is minus 8 equals minus 7, which can't be solved. Okay, so let's visualize what's going on there. So we can't find a point of intersection, so it's not going to be the one where it's a point of intersection. But let's visualize what's going on here. We have our plane with our normal vector. Our normal vector is 1, minus 2, 1. We have a line, and that line is now, we've deduced it's now either going to be exactly on the plane, or it's going to be parallel to the plane. And we can even show this, because if it's going to be parallel to the plane, then it will definitely meet at a right angle. So therefore the direction vector of the line will meet the right angle at a dot product of 0. Let's just show that. So it's going to be 1, minus 1, minus 3, dotted with 1, minus 2, 1, which will equal 1 plus 2 minus 3, that will equal 0. So therefore the line and the perpendicular to the plane meet at a right angle. Okay, so what we still don't know then is whether the vector for line L is going to be on the plane or parallel to the plane. So what we now need to do is to check whether a coordinate that's on the line will also be a coordinate on the plane. Because if that's true, then the line will be contained within the plane, or if it's not true, then the line will just be parallel to the plane. So what I do know is that the coordinate minus 2, 5, 4 is on the line. So what I'm now going to do is I'm going to substitute it into the equation of the plane and see if it does lie on the plane. So substituting x in, y in, and z in, I'm going to get minus 2 lots of 5, and then plus 4, and that's going to equal minus 2 minus 10 plus 4, and that's going to equal minus 8, which does not equal minus 7, so therefore minus 2, 5, 4 is not on the plane, so therefore the line is not contained within the plane, so therefore the line is parallel to the plane. The line is parallel to the plane. Okay, so there we are. That's the answer for this question here, that the line is parallel to the plane. Quite a difficult question. I would have to have some understanding of lines and planes and what the perpendicular means, etc., etc. So yeah, pretty tricky little question, that one. That's the answer for question 4. That was worth 5 marks. Let's now move on to question 5.